Hello everyone, welcome back to OLMJ, and today we'll be covering the best maths question from Narayana test series. So I'll be uploading the best questions from test series of various coaching institutes. Let me know if this is helpful. So first question is, let A is a set which contains 1, 2, 3, 4, 5, 6, and f is a function from A to A such that the equation f of x is equal to x has only 4 solutions. If the number of such functions is n, then okay, so we are given that A is a set which contains 1, 2, 3, 4, 5, 6, and we have to map from A to A. So this is A and this is also A. So we have to map functions such that f of x is equal to x. So for f of x is equal to x, there are two cases when this is possible. First is when f of x is equal to x, right? Because if f of x is equal to x, then f of x will become f of x which is equal to x. So this is the first case, and the second case is when f of x is y and f of y is equal to x, right? Because then f of x will become equal to f of y, which will be equal to x, and f of y will become equal to f of x, which is equal to y. So if we have this cross linking, then both x and y will satisfy this original thing. So let us solve this question. So first since this has only 4 solutions, then only 4 of this elements from the domain should satisfy either of the conditions. So let us first select 4 numbers. So number of ways of doing that is 6c4, right, which is 6 factorial by 4 factorial by 2 factorial. So this will be equal to 15. Assume that the 4 numbers are 1, 2, 3, 4. So these will be satisfying the condition that f of x is equal to x. So there will be 3 cases total. Either each number maps to its own number number in the range. So that will be f of x is equal to x for all 4 numbers. So this has only one case. The second case is that f of x is equal to x for 2 numbers and remaining 2 are cross-linked. So we can select 2 numbers from the 4 numbers. So this will automatically fix the other 2 numbers which will satisfy f of x is equal to x if we select the 2 numbers which are cross-linked. So this will become 4 factorial by 2 factorial, 2 factorial, which is equal to 6. right? And the third case is when uh, two pairs are cross-linked. Means that all four numbers are cross-linked. So we can select similar similar to the way in which we did the second part. We can all select two numbers. But there will be double counting here because imagine you selected 1 comma 2, so that will automatically mean that 3 comma 4 are cross linked, right? But you are again selecting 3 comma 4, which will imply 1 comma 2, so this will be double counting. You need to be careful here because this is a very hidden case of double counting which many people will miss. So we will take 4c2 by 2, so this will give us 3 cases. So total cases are 1 plus 6 plus 3, which is 10. So now the remaining two numbers, except these four numbers, so 5 and 6, since we assumed it to be 1, 2, 3, 4, 5 and 6 can be mapped to any number except for 5 because it cannot satisfy f of x is equal to x, and 6 cannot be mapped to 6, and there is one more case that 5 cannot be mapped to 6 and 6 cannot be mapped to 5, right? So remaining two numbers have 5 into 5 minus 1 options. Five options for 5, 5 options for 6, 5 and 6 cross-linked. So this gives us 24 cases. So answer will be equal to 15 into 10 into 24, which gives us n is equal to 3600. Okay, so n will become 3600. So it is a perfect square. So you can check the other options also. So 3600 can be if you check the other options, then you will find out that 3600 has 45 divisors, so B is wrong, and it has only 3 prime factors, 2, 3 and 5, so C is wrong, and D is also wrong because it has 45 divisors. So the answer for first question is A and C. So the second question says that Tejas had drawn the following figure without lifting the pen and without retracing already drawn path again. Let n be the number of ways he could have done it. Then the number of perfect square divisors of n is. So Tejas needs to draw this diagram and he cannot lift the pen or retrace the path he has already drawn. So he must start from one of the extreme ends on the upward or downward side, because if he does not start from here and instead he starts from here, then he'll need to go downwards and then he'll go back upwards and he'll retrace the path, or he can go upwards first and then he'll need to come downwards, so he'll retrace all this path again. So he must start from one of the extreme ends, and he cannot also start from a loop, because if he starts from here, then he will first go here, then he'll have to go back here, and to go downwards he'll need to retrace the path he has drawn. So he cannot start from one of the loop, so he must start from here if he's starting from the upward direction. So he must start from here or here. So first I'm assuming that he's starting from the downward point, so he'll go upwards. So there is only one way of covering this path. then he can choose the order in which he'll draw these loops. First he can draw this loop, or first he can draw this loop and then this loop. So that can be done in 2p2 ways. Okay, so let us consider one case of 2p2 where he first chooses to draw this loop. So he'll either go in this direction, which is anti-clockwise, or he can go clockwise direction. So this gives us two more options, and he can, when he reaches back to this point after drawing the loop, then he can draw this loop in anti-clockwise or clockwise direction. So two more options. So 8 options till here, and he has reached this point again after drawing these two loops. Then he'll go upward, so one option only, and then he needs to draw these 3 loops. So these 3 loops, he has to choose the order in which he draws them. First he can draw this, then this, then this, or he can draw this, then this, then this. So this can be done in 3p3 ways, and each loop again has the option of clockwise or anti-clockwise. Assume that he is drawing this, then this, then this. So he can either go in this direction or he can go in this direction. So two ways. Then he'll draw this either in this direction or this direction. Similarly, this has also two ways. So this is 2 into 2 into 2 ways, right? So this covers the cases when he's going from the downwards point, and if he's starting from this point, then also he'll have the same number of ways of drawing, because first he needs to choose this three order of 3 loops, then the anti-clockwise and clockwise. So this part is covered. Then he'll come downwards, and then he'll also choose the order and the anti-clockwise. So this part is covered. So we will multiply this by 2 for upward and downward point. And these 2's were the anti-clockwise and clockwise thing. And this 2p2 and 3p3 were order of loop. So this will give us 2 into 2 into 2 into 3 into 2 into 2 into 2 into 2. So this is 2 into 8 multiplied by 3, and this comes out as 768. So they are asking for the number of perfect square divisors of n. So if the divisor is a perfect square, then it must have even power of the prime factor. So for 2 it can either have 0, 2, 4, 6, 8 for 2, and for 3 only 0 is possible. So this has 5 options and this has one option only. 5 into 1 is 5. So the answer is 5. This was a bit tricky if you didn't consider the anti-clockwise and clockwise thing. So moving on to question 3. It is asking that let an be the number of ways to form a number using the digits 1 and 2 only, such that the sum of digits is n. All digits can be 1 or 2. Then, okay, so an is the number of ways of forming number using 1 and 2, and n is the sum of digits, right? Okay, so this is a bit tricky question. So assume that an minus 1 is number of ways of forming number which has sum of digits as n minus 1. So assume that this is a random number and the last digit, if it is 1, then it will give us um, it will form the number which has sum of digits as n, and it has only one possibility, 1, right? So if we consider a n minus 2, so it will be the number of ways of forming number which has sum of digits as n minus 2, and if the last digit is 2, then sum will become n, right? So since there is only one possibility, so if we add an minus 1 and an minus 2, then we'll get all the possibilities of forming the sum of number which has sum of digits as n, because there is only one possibility here, right? So if we add these two, then we'll get an. So an will be equal to an minus 1 plus an minus 2, right? So this is the main formula which we will be using to solve this question. So let us see. So a0 will be equal to 1, because forming a number which has sum 0 is only possible in one way, empty string where we don't use any 1 or 2. So it has one possibility. A1 is also equal to 1 when we take 1. So a2 will become equal to a0 plus a1 using this formula, which is 2. a3 will be equal to 3. a4 will be equal to 5. a5 will be equal to 5 plus 3, which is 8. a6 will be equal to 8 plus 5, which is 13. a7 will be equal to 21. a8 will be equal to 21 plus 13, which is 34. a9 will be equal to 34 plus 21, which is 55. a10 will be equal to 55 plus 34, which is 89. So let us see. a10 is 89, this is true. a9 is 55, so option A is wrong. So C is a10 minus a9, which will be a8, which is 34, this is right. a9 plus a10, 55 plus 89 will be, which have unit digit as 4, so this has 3, so this is wrong, right? So the correct option is B and C. Hope this is clear, that if we take an minus 1 plus an minus 2, then it will give the total number of ways of forming number which has sum of digits as n, because there is only one possibility of last digit being 1 or 2. So we will basically multiply this by 1 only and multiply by 1 only to get the number of ways of forming an. So we'll adding both the possibilities. Question 4 says 4 persons are playing a game of toy gun shooting at midnight. Each person randomly chooses one of the other 3 and shoots him. Everyone is able to shoot before he is possibly hit. The probability that exactly 2 persons are shot is. So let us first choose the 2 persons out of the 4 people who will be shot. So that will be 4C2, right? So let us take ABCD. So 4C2 gives us, let us assume that B and C are chosen, right? So A has 2 options now. A can shoot B or C. B can only shoot C because he cannot shoot himself. C can only shoot B, and D can only shoot B and C, right? And the probability of shooting each person is equal, so this will be equal to 2 by 3 possibility. This is 1 by 3. This is 1 by 3. And this is 2 by 3. A can shoot B or C. This has possibility 2 by 3. This has 1 by 3. Right? Because no person can shoot himself. So the final answer for this question will be 4C2 multiplied by 2 by 3 multiplied by 2 by 3 multiplied by 1 by 3 multiplied by 1 by 3. So 4C2, let us calculate. So this will be 6. So 6 multiplied by 4 by 9 multiplied by 1 by 9. So this will be equal to 24 by 81. And it is given that P and Q are co-prime. So we need to reduce this into the minimum fraction. So this will be 8 by 27. So P is a perfect cube. Yes, this is correct because 8 is a perfect cube. Q is a perfect cube. Yes, this is 3 cube. And Q minus P is equal to 19. Yes, this is correct. And 3P is less than Q. This is also correct. So the answer will be ABCD for question 4. Moving on to question 5. This is a bit difficult question. So let us see. Let G be a function from R to R, and it is a differentiable function such that G dash 0 is not equal to 0. And F is a function from R to R such that G x plus y is equal to Gx plus Gy plus 1 for all x and y belonging to R, and G of, there is one more relation between G and F given, for all x belonging to R. So if F is a continuous function on R and F of 2023 is equal to F of 2025 is not equal to F of 0, then F of half plus F of 2 is asked. So let us start. So first we are given that G of x plus y is G of x plus G of y plus 1. So whenever we are given such type of functions, then we have already remembered the solution to these kind of functions. But this is a bit different from the functions that we remember. We remember for Gx plus y is equal to Gx plus Gy. So let me introduce another function in terms of G, which is fx is equal to Gx plus y, Gx plus 1. So fx plus y will be equal to Gx plus y plus 1, which will be equal to Gx plus Gy plus 1 plus 1. So this will be equal to h of x plus f of y, h of y, which finally gives us hx plus y is equal to hx plus hy. And we know that the solution to these kinds of function is that hx will be equal to ax, because you see that if you put ax plus y, then it will multiplication is distributive, so it will become ax plus ay, which is equal to hx plus hy. So this is a valid solution. So this will give us gx is equal to ax minus of 1, since gx was hx minus 1. So we have a function for gx now. So, and we are also given that g dash 0 is not equal to 0. So g dash of x will be equal to a, and we are given that g dash of 0 will also be equal to a, because this is a constant. So, and this is not equal to 0. So a is not equal to 0. This will be used later. Now we are given this relation between g and f. So I am replacing g everywhere by ax minus 1. So this will become, so this is x here, right? Because the thing inside the bracket is assumed to be x. So this will become a of a multiplied by f square x plus 2 minus 1 plus a of x square f square x minus 1 minus of a x square fx minus minus 1, which will become plus 1, and minus of a 3fx, a multiplied by 3fx plus 1 is equal to 0. So these constant terms will cancel out, minus 1 minus 1 plus 1 plus 1, and we have already proved that a is not equal to 0, so we can cancel out a also. So I will cancel out a. So this will finally give us f square x multiplied by x square plus 1. I am taking together all the terms containing x square x, and I will also take all the terms with fx. So it will give us multiplied by minus x square minus 3 plus 2 is equal to 0. So from here we can use the quadratic formula and find out fx. So it will come out as minus b, which is x square plus 3 plus minus of b square minus 4 a c by 2a. So this will become x square plus 3 plus minus of, inside it will become x raised to power 4 plus 9 plus 6x square minus 8x square minus 8 whole divided by 2x square plus 1. So this will become equal to x square plus 3 plus minus of x square minus 1 whole square divided by 2x square plus 1. So this will finally give us fx is equal to 1 comma 2 by x square plus 1. These will be the two solutions for fx that you will get on solving this quadratic formula. And we are given that f of 2003 is equal to f of 2002, 24. So if we take this function, then f of 2023 will not be equal to f of 2024, right? So at x is equal to 2024 and 2023, fx must be equal to 1, so that f of 2024 is equal to f of 2023, right? And at x is equal to 0, fx must be equal to 2 by x square plus 1 and not equal to 1, so that f of 2024 is not equal to f of 0, right? So fx is a piecewise function, and we are also given that fx is continuous. So where the function is changing, there the function should be continuous. So we can see that if we solve this, then we will get that x square is equal to 1. So this will give us x is equal to plus minus 1. So valid fx can be given as 1 if x is greater than 1 and 2 by x square plus 1 if x is less than of 1, right? So from here we will get that because at 1 this will also be equal to 1 and this will also be equal to 1, and these two conditions are also satisfied. So the function will be continuous and these criteria is satisfied. So this is valid fx. So now we have to find f of half plus f of 2. So f of 2 is equal to 1 and f of half is equal to 2 by 1 by 4 plus 1. So this will be 4 plus 1 is 5 and 4 multiplied by 2 is 8. So 8 by 5. So 8 by 5 plus 1 is equal to 13 by 5. Okay. So the answer will be 13 by 5, which is option C. The next question says that if A is a 2 by 2 matrix with terms named as Aij and B is a 2 by 2 matrix with Bij as its elements, such that Aij is given by f of x raised to the power 2i minus j minus 2 and Bij is given as this, and A plus B transpose is given as this, then we have to find this integral in terms of f of 1, right? So let us first write what will be A and B matrix. So Aij is given as f of x raised to power 2i minus j minus 2. So A11 will be equal to f of x2 minus 1 minus 2. So f of 1 by x. A21 will be equal to f of x4 minus 1 minus 2, which is f of x. A12 will be equal to f of x2 minus 2 minus 2, which will be f of 1 by x square. A22 will be equal to f of x raised to power 4 minus 2 minus 2, which is f of 1, because this will be 0. So A matrix will become f of 1 by x, f of 1 by x square, f of x and f of 1. And similarly, if you calculate the terms of B, you will get that B is equal to f of 1, f of 1 by x, f of x square, f of x. So A plus B transpose will be equal to f of 1 by x plus f of 1. This will be f of 1 by x square plus f of x square, f of x plus f of 1 by x, and this will be f of 1 plus f of x. So on comparing this matrix and this matrix, we will get 4 equations, which will be f of 1 by x plus f of 1 is equal to minus x square multiplied by f of x plus f of 1, f of 1 by x square plus f of x square will be equal to 1 minus 1 by x raised to power 4 multiplied by f of 1 by x square, f of x plus f of 1 by x, it will be equal to f of 1 by x multiplied by 1 minus 1 by x square. Then last equation will be f of 1 plus f of x is equal to minus 1 by x square, f of 1 plus f of 1 by x So if we put x is equal to 1 here, then we can see that this bracket will be equal to 0. So we will get that 2 of f of 1 is equal to 0, which will give us that f of 1 is equal to 0, and assume this is 1. Using this in 1, we will get that f of 1 plus 0 is equal to minus x square. Sorry, this was 1 by x. I'm not putting x is equal to 1. I'm taking that f of 1 is equal to 0. So minus x square multiplied by f of x. So this will give us that minus 1 by x square f of 1 by x is equal to f of x. This we will be using later. So we need to find this integral. So let me write it. So let this be equal to I. Now if I replace t by 1 by t, because whenever we have limits as the limit as x and its reciprocal, so we can take 1 by t, because we will see later why I am taking 1 by t. So this will also give us that dt is equal to minus 1 by t squared dt. So I will become equal to, so limits will change from 1 by x and x, f of 1 by t minus 1 by t square dt, and if I take this minus outside, then the limits will interchange once again. So it will become so 2I will be equal to f of t plus 1 by t square f of 1 by t dt from x to 1 by x, and using this thing we'll find out that these two terms will get cancelled out. So this will become 0 dt. So 2I will be equal to 0. So I will also be equal to 0. So we'll find out that f of 1 was also equal to 0. So I is equal to f of 1. So this thing is equal to 0, which is equal to f of 1. So option A is correct. So that is it for today. We covered 6 good questions from Narayana test series, and let me know if you want similar type of videos from other coaching institute test series like fiitjee, AITS and Allen AIoT. I will upload it, and let me know if you want for physics and chemistry too. So don't forget to like and subscribe, and bye.